All right, so chapter 2. Oh, let's also maybe put, I mean, pretty much 2.1, section 2.1 is just titled derivatives as well, but if you want to squeeze that on there, section 2.1, derivatives. We could title it derivatives with limits. Because again, eventually they're going to go away. Okay. All right, so what is a derivative? It is an expression to find the slope at one point on a curve. Okay, so to find the slope at one point on a curve. Up until now, how many points did we need to find slope? 2 points, and that was not for a curve, but for a straight line. Okay. So this is the concept, and we even go into calculus 2. The goal now is like any equation that I give you, can you find the derivative? That's where we're at. And then we'll kind of use it in different situations, but for this chapter, next chapter, and part of Calc 2 is here's an equation, can you find this derivative? Can you find the slope at only 1 point on a curve? Now, don't forget slope is the same thing as rate of change. Rate of change. That's kind of why it pops up like more in a word problem, a rate of change. Also velocity. That's kind of what came up when they were doing stuff in physics. They said, I need the rate right here at this point. And that's how they decided to start doing calculus and tried to figure out how do I find the rate or the slope at 1 point. What else do we want to say? Oh, also, we can also put another way to think of it. We can also do this. Also, it is the slope of the tangent line. It's the slope of the tangent line at that 1 point. At that 1 point. What does tangent mean? Let's write it. Also, it is the slope. Again, it's still slope, but it's kind of another way to say it. I think our book uses this more, especially at the beginning. The slope of the tangent line. Oh, that's what at that 1 point. Tangent means just kind of touches it one time and then keeps going on. Okay, kind of like a brush fire. All right, but it literally touches it at that 1 point and then keeps going. So we'll see a picture of this today to help just a little bit more what that means. I like this definition, but this helps you see it more visually. You get to see it as a tangent line. So we'll talk about those two in just a minute. All right, so we did that, we did that. Okay, so let's take a look. Let me get a new page. Okay, so let's just sketch something basic. Let's do a parabola. Here is the point that I want to find the slope at. A. What they did is they went ahead and picked another point, and they called that X. And then don't forget over here, this would be f of a, right? Technically the y value, but we like to write it as f of a. And this one up here would be f of x. Now, if I use those actual 2 points, I zoom in a little bit more. Does that help? If I use those actual 2 points, I would get the slope of this line, which I'm kind of close, right? But technically that parabola is curving, okay? I would probably actually, if I did a better drawing of my parabola, my line would probably go inside it. Does that make more sense? This is probably a bad drawing. Let me see if I can draw it a little better. This would probably is what my parabola would look like. You don't have to draw this green line. but this is probably the line that I would get. But what they said is, okay, what happens if I move this x value a little bit closer? And found the slope with a and x again. Moved x, I should go this way, moved x a little bit closer. Moved x a little bit closer. What is that? It's approaching a. And that's where they said they could do the limit. So they said that the slope, okay, let's write this down. y2 minus y1, right? What is that? That's just how we find slope with 2 points, right? y2 minus y1 over x2 minus x1. Who can fill in using these 2 points? My y2 would be f of x. So f of x minus f of a over x minus a. And that's really what we use. Now we'll talk about, we adjusted just a little bit, but that's what we use. We want this x to get closer and closer to a. So we take the limit as x approaches a. Because we don't want this space. We don't want to just use these 2 random points. I guess it would be like this, right? We want to bring this x value closer and closer to a until those 2 points are so close that when we calculate the regular slope, y2 minus y1 over x2 minus x1, it gives us the slope at that 1 point. That's the goal. So this is m. Now, remember we said we do this for every single equation out there. So we're not going to do that, but this isn't always the best situation. So we're going to just adjust this a little bit. I like this because you can see literally y2 minus y1 over x2 minus x1. The other way we just adjust it just a little bit. Let's, well, maybe I can do it up here. Let me get it right. What they did is they called this distance here h. The distance between x and a, they called that h. So if I'm moving that x value towards a, I want x to approach a, but now if I call that h, what value do I want h? If I'm moving this way, I want h to approach 0. Yeah, and 0 is a good number to work with. So you see how they kind of like this other one? This is a good one, but we're going to use this other one too. Every book uses it. Like I said, for the easier ones, we probably could get away with this, but the harder ones, they like this one better. So the limit, you probably can't see this. Let me set this up. So the limit as h approaches 0. Now let's take a look. Let me do this for right now. Let me pull this up. So we'll come back. I might have to unfold that, but this might work better for right now. Okay, do we see, yes, a is an x value, but you can also think of a as the distance from the x-axis over, right? If this point was, let's just say it was 3, 5, I would go over 3 and then up 5. So I can also think of a as a distance of 3, or a distance in general. And same thing with h. So what would a plus h equal? A plus h would equal x, right? Does that make sense? If this was 3 and then this was 2, that would also mean that I went over 5. And you're not going to have to reproduce this. So once we get it, you're just going to have to remember. So don't panic completely, but I just kind of want you to always see where stuff comes from. All right, so if we solve this for h, if I solve that for h, I would subtract a. And so h is equal to x minus a. Okay, so now let's go back. Now we don't need the picture as much. Let's go back to this guy. So in place of x, instead of x, can we see this? Instead of x, I'm going to put a plus h. So now let me write it one more time. The limit as h approaches 0. I'm going to go back up here. I'm going to use this, but instead of x, I'm going to do a plus h minus f of a. That's okay. And then look what I can put on the bottom. Instead of x minus a, what can I put? H. Instead of x minus a, I'm going to call it that h. Okay? And that's the one that we're going to use. But remember, this really comes from nothing more than slope and moving those 2 points closer and closer together. That's really all they did. They said, hey, I'm still going to pick 2 random points, and then I'm just going to push them closer and closer together. And then eventually those two will basically like merge, and I can still find the slope that way. And this is just a variation of that y2 minus y1 over x2 minus x1. Okay, so we did that. Don't forget, and what does this whole thing find you? It equals m. Why does it equal m? Because that is slope. We're using it to find slope. Okay, so now let's rewrite it one more time. Let's label it too. I think that'll be good too. So I wrote the derivative of a function. Pause for a second. Okay, the derivative of a function. This is kind of important, so maybe it will be good to write the derivative of a function at a. Because right, because we have to decide where we want the slope at. So the derivative of a function at a. And this is the notation. So far we've been doing m, but the notation for derivative is f prime of x. That is derivative. And then that's equal to, it won't hurt because we're going to use it a lot, the limit as we're going to do as h approaches 0 of f of a plus h minus f of a all over h. Now, when they were doing this, they were all kind of working on this, but all throughout Europe. And they couldn't just get on the web and say, hey, I'm doing this, hey, I'm doing this. So throughout, they use different notation. And actually, it actually is all meant to be. You can all kind of see how it works out, because sometimes this isn't the best notation. Right? Change a y over change an x. So other notation for derivative. Notation for derivative. I use this a lot. So that would be one for sure. But change of y over change of x, dy over dx. That can also mean derivative. Sometimes we don't know specifically why. So sometimes we just do d over dx. Sometimes it doesn't necessarily have to involve y. So, and we'll talk about that. There's a few times when we use that. I don't use this as much. I think this came about just for like typing. It was easier. They would do d, capital D of f of x. You got to remember, even in the 70s, it was hard for textbooks to type. They did do a little subscript. They did like d sub x of f of x. All right, I think that's pretty good. Oh, and we can also do, I forgot, instead of like function notation, we could just do y prime or whatever it's called. Okay. So I would say these four, I don't know if I'll use this at all, but just in case you ever see it, they're just asking for derivatives. Okay. But yeah, these, I would say at some point we'll use all four of these. But this one by far the most. All right, so let's put this into practice. Are we ready? Oh, one thing I wanted to say, where was that? The definition that we wrote is the derivative is an expression. We're not going to see that part yet. We're going to go right to finding the slope, okay? But eventually, and in a couple days, we'll talk about all our answers are going to be like 3x plus 2. That's the expression that we would use to go find the derivative, to go find the slope. Okay, but today we're going to go find the slope right away. So don't panic about that part. The main thing right now, get in your head, derivative goes with slope at only 1 point on a curve. It works on a line too, but we've got other means. Okay, so let's take a look. There's 2 parts. So these are our examples. We're going to find the slope. Find the slope. We'll go through. We'll see how many examples we can get to. If we get to 3, great. 4 would be perfect. So we'll see how we do. We're going to find the slope of the tangent line. So we'll talk about that a little bit more, what we mean by that tangent line. At 2, 6. So they have to give us at least 1 point still. We've got to find the slope somewhere because the slope is always changing. If it's a curve, it's never going to be the same. Kind of a line is always the same, but on curves, it's always going to be different. So we got to have at least 1 point. Where are we finding the slope? Okay. And then B, we're going to write the equation of the tangent line. Right. Pretty much eventually, if they ask us to do B, in order to write the equation of a line, you have to have slope. Okay, so they don't necessarily even have to ask us for A because we had to find slope in order to write the equation of a line. All right, so, okay, so let's start. We're going to find slope. Let's also just get in the habit of, we're going to find this derivative. The limit as h approaches 0. Oh, I have to give you the equation. That would be helpful, wouldn't it? Let's see if we can sneak it up here. We got to do the equation. Y equals 5x minus x squared. That would probably be helpful. All right, so let's finish up. Okay, so the limit of, what is it? F of a plus h minus f of a all over h. So let's see if we can understand what we're doing. And then I'll zoom back out. Okay, so here's my equation. 5x minus x squared, that's the one I gave you. So let's graph it. There's that guy. Okay, and now I'm going to hit trace and 2. I want to find the slope right there at that point. That's what I want to find the slope of. I want to find the slope of the tangent line. So we'll also draw on the tangent line when we're done, so you can kind of visually see what that looks like. But I want to know the slope right there at that 1 point on the curve. All right, so we'll come back to that guy. So let's use this. Okay, so let's do the limit as h approaches 0 of f of, now what is A? A is the value that the x value that we're trying to find the slope at. So that is 2. In fact, a lot of times they don't even give us y. We don't really need y unless we're going to write the equation of y, but we could actually plug the 2 in and come up with the 6 on our own, to be honest. But they're nice enough to give it for us. But A is the x value where we're trying to find the slope. A is the x value where we're trying to find the slope. So it's going to be 2 plus h minus f of 2 all over h. Okay, so now what does this mean? F of 2h, that means I got to put a 2 plus h into here. Okay, so we got to do 2 plus h into there, then we got to do a 2 into there. That's nice, that'll give us a numerical value, and then we got to think about the limit. Okay. So the limit as h approaches 0 of 5, and then instead of x, I'm writing 2 plus h minus, instead of x, I'm writing 2 plus h squared. And then minus, this is important. Where's my red? Always get in the habit of putting this in parentheses. We don't really need it here, but because of that minus sign, those red brackets, you're probably going to use every time. So minus, and then I'm going to do a bracket. Maybe should even put those in, because like I said, we don't need them here, but we're going to need them every time we put the numbers in. So because this is a minus, we need those brackets. All right, who's going to tell me what I'm going to write here? Does anyone want to try? 5 times 2, right, because that goes in there, minus 2 squared. Good. And then don't forget all over h. Okay. So now our algebra kicks in. We got to simplify all that stuff on the top. Okay. So distribute. Okay, so let's write the limit as h approaches 0. Distribute there. That's not too bad. So 10 plus 5h. Now be careful here. Same thing. Because of this minus, you've got to think of those brackets. Okay. So I have this minus, and then I had to write this out. Maybe I'll put the brackets even in. 2 plus h times 2 plus h. And then this isn't too bad. 10, just don't forget your minus. Maybe we can even sneak it up here, though we're going to be writing a whole bunch. But 10 minus 4, so that is going to be minus 6. That's fairly important. Make sure you do all that work and then the minus. These brackets are very important. You're going to need them every time because this is always going to be minus. Okay, so now, and don't forget all over h. We got 10 plus 5h hanging out there, minus bracket. Now we got a FOIL. First gives us 4. If you want to take a shortcut, outer and inner together, so 2h plus 2h would give us 4h, and then plus h squared. You don't have to take that shortcut. All over h. Okay. You need those brackets though, because now everything's it's going to be 10 plus 5h minus 4 minus 4h minus h squared. You must distribute that, and then we have the minus 6. So you really are going to have to watch your minus signs. It would be nicer if they give us 5x plus x squared, but watch your negatives. Okay, so now what happens? Now we're finally at a place we can collect like terms. What happens there? That actually gives us 0, right? That gives us 6 minus 6, so that goes away. So I have, oh, and let's do this. We've got 5h minus 4h. That gives us 1h. So we got 1h minus h squared all over h. And don't forget, we're taking the limit as h approaches 0. Okay, can these h's cancel? No. But what do we want to do on the top? We want to factor the top. Take an h out. Take an h out. So now if we take an h out, what's left here? We have to still write something. 1. Make sure that you write a 1 there. 1 minus h over h. Look at that. Look how good that looks. Now can I cancel the h's? Yes. And how do I evaluate that limit? Plug in the 0. 1 minus 0. We did all that work for a great answer of 1. And this is where I need now. Does anyone even remember what that 1 stands for? We do all that work, we get credit. That is slope. That is the slope. That is the slope. So, I'm running out of room here, but okay, so slope was 1, and we were doing it at the point 2, 6. I had most of my answer to begin with, right? If I'm supposed to write, so this is A. A was find the slope. B is can you write the equation of the tangent line? Look at how much I had to begin with. Y minus y1 equals m parenthesis x minus x1. From the beginning, I knew it was going to be y minus 6 equals m x minus 2. But what did I do all that work for on that other page? Slope, which was a beautiful answer of 1. Now, that answer is fine, but WebAssign, at least for today, and we're not going to do this a ton, a couple days, WebAssign makes us solve for y. So let's go ahead and solve it for y. Distribute the 1, that doesn't change anything. So y minus 6 equals just x minus 2. And then if we add the 6, x plus 4. Most of the time, we'll stop before we even find slope, and that's why that definition talked about an expression. But it's kind of cool to write this tangent of the line, because that's the only way you can visually see it. Okay, so let me call this back up. So it's great, and then I'll bring it back. It's great that I can now tell you that flashing point has a slope of 1. But you still don't really see it. How do we know for sure? So I went and typed in, hopefully we found x plus 4. Okay, so I typed in x plus 4. And now we can get a visual because it's also a tangent. Do you see how a tangent comes and just touches and then keeps going? And so that's now a guarantee that we did find the slope of the tangent line. If it was, you know, if we had this and we found the line, the equation of our line was this, do we see how that's not a tangent? Now, if the graph, oh dear, we can barely see. How about that? Do we see how that's not a tangent? Okay. If our graph looked like this, and you could just watch, if the graph looked like this, and our tangent line eventually like cuts it over there, that's fine. That's not an issue. So there will be times where you'll be like, hey, it's going through. It's definitely not a tangent here, but it would be classified as a tangent here. The tangent just kind of brushes and touches. So it's kind of nice today that we have to find the equation of the line. Because if you have a calculator, I think there's one where they ask you to pick which graph it is. It'll be easier if you have a calculator, but if you don't, you can kind of still go through the process in your head. But it's kind of nice you can see that officially is the tangent. Okay. All right, let's try another. So same direction. Yeah, this one even, I think they changed it on our notes or on our homework. This one just says write the equation of the tangent line. To write the equation of the tangent line, what do you have to find? You must find slope. So whether it specifically asks you for A or not, the first thing you got to do is find slope. All right, so it is, the problem is y equals x squared plus 3x minus 2, and it's at the point 316. Okay, I gotta move it. Oh, thank you. Oh, let me, I think I could assume. Okay, and this looks messy, so let me read. Then I'll give you a second. 316. All right, so we're finding The equation of the tangent line. Should we write that? Find equation of tangent line. Can we see any of this? No. Find equation of tangent line. Otherwise, I guess we could use A and B, same thing that we wrote earlier. Okay, all this work is for one thing. What do we have to find? We got to find slope. M, which is the same thing as the derivative, is equal to the limit as h approaches 0 of f of a plus h minus f of a all over h. So that we got to remember. And what is a? A is 3. A is that x value that I want the slope of. Because if x was 7, would it have the same slope? Probably not, because we're talking about a curve, so it's constantly changing. So I have to know this one is specifically when x is 3. So here we go. Limit as h approaches 0, f of 3 plus h minus f of 3 all over h. We can actually take a little bit of a shortcut. Okay, so let's start it. Let me show you where that shortcut is. If you're ahead, you're okay. I'll kind of warn you where the shortcut is. This is going to be a little, it's pretty much the same. We have to do 3 plus h, and then we have to square it. Remember, that whole thing is going in for x, plus 3 times x, which is 3 plus h, and then don't forget minus 2. Then there is this minus sign, and then there is a bracket. Now we're supposed to plug in 3, and you can. A lot of times I just do it, but this problem they happen to tell us, right? What is 3? 3 better produce an answer of 16. So if we want to take that shortcut, we could say, hey, I already know this. You gave it to me. It's got to be 16. And if you forget and you just plug it in, that's okay too. As long as you get 16, it's okay.
Can we do that for everyone?
Yes, yes, yes. The only thing is tomorrow it's going to change already, but take advantage today. Absolutely, yeah. So that other one, when we spend a little time doing the arithmetic, and if you plug in the 3, you're probably going to do it with on a calculator quick anyways, but for less chance of error, yeah, definitely you could plug that in right away. Absolutely, yes, and that's for everyone, yeah. Good. All right, and don't forget all over h. Okay. And then it's up to you. We gotta write this out twice. Let's see, we're running 3 plus h, write it. Oh, 3 plus h squared is not 9 plus h squared. We had that a little bit on the test. No, you gotta write it out twice, people. It's not that easy. So take advantage of this shortcut. That other one is at 9 plus h squared. What is it gonna be? It is gonna be 9, and it is gonna be h squared, but there is a middle term. What is it? 6h, right? Don't forget 3h and another 3h, outer and inner. You could take that shortcut too, but you've got to have 6h plus h squared. It is not 9 plus h squared. You have that middle value. And without that, this turns out to be a lot harder. You'll probably realize it because things aren't going to cancel out. With that, more things will cancel out. Okay, where are we? Okay, we still have, so that is this. Maybe I'll do it in a different color. This then is 9 plus 3h. We just have to distribute there. And then we still have the minus 2 and then the minus 16. Okay, so now what happens when we do, maybe I'll do red. Don't forget, sometimes I don't write all over h, but just don't forget that that is there. Okay, that would be another shortcut, but just don't forget that that is there. 9, negative 2, and negative 16 gives a 0, right? That goes away. Nothing else does though, right? So this will give us 9h. Oh yeah, that's right. 9h, okay, just want to make sure, okay. And then plus we still have, what do we still have? We still have the h squared. There it is. Okay, now if you haven't forgotten about it, make sure you bring that h in and the limit as h approaches 0. Okay, the h's do not cancel either way, but you're on the right track. What do we have to do so that they do cancel? We must factor. Okay, so take an h out. Okay, if we take an h out, we've got 9 plus h over h. The limit as h approaches 0, the h's cancel. Now we can plug that 0 in and get a slope of 9. Okay, and then we had 2/3 to begin with. We did all that work for 9, but don't forget y minus y1, which is 16. Go back to this side. And then equals, should I write this? Y minus y1 equals m x minus x1. And then all that work was for that 9 and then x minus 3. Distribute the 9. So, and that answer is fine, but if you want to graph it, or I think WebAssign makes us solve for y. So y minus 16 equals 9x minus 27. Distribute that 9 and then add 16. Y equals 9x minus 11. So remember, all this information, this is the slope of the, or this is the equation of the tangent line on this original parabola. Because it's an x squared, we at least know it's a parabola. And if we graph this parabola at 316 at that point, this line should have barely touched it. Okay? And if we just are doing like velocity, we probably won't need this. We'll just need to know it's a velocity at 9 right there. So a lot of times we'll stop here if we don't even stop a little bit soon. Okay, so we may not, should we start this one? Yeah, let's start it. I think we can get through it. And then we won't have, oh yeah, we have to get through 3, right? Oh yeah, we have 2 more. Okay, yeah, we gotta get through this one. All right, f of x equals the square root of x minus 4. And we're talking about the 0.82. Okay, so yeah, we do have to get through. Okay, we're writing the equation of the tangent line. We know it's gonna be y minus 2 equals m x minus 8. But we need that m. How do we find the m? We deal with that limit. The limit as h approaches 0 of f of a plus h minus f of a all over h. Okay, and what is a? A is 8. A is that x value. So the limit as h approaches 0 of 8 plus h minus f of 8 all over h. Okay, so in place of x, we're plugging in the quantity 8 plus h. So remember, this tells us to go to the f function. So it's going to be the limit as h approaches 0 of, go to the f function, 8 plus h, and then I still have minus 4. Minus this minus is this minus, and we need brackets. We either plug the 8 in, and it's almost as short, but what should the answer be? The answer better be 2. And so we can take it from there if we want. Otherwise, you can see 8 minus 4 gives you 4, square root of 4 is 2. And then all over h. This square root goes over the 4, so it does go over this. Okay, so under the radical, 8 minus 4 gives us 4, and then we have plus h. And then we have this minus 2 all over h. How do we, let's see, how do we solve that limit? That was on our test. Conjugate, right? Conjugate. So we're going to multiply top and bottom by the square root of 4 plus h plus 2. Square root of 4 plus h plus 2. Did that in chapter 1? Slide it up. All right, square root of 4 plus h times the square root of 4 plus h. You have to FOIL the top. That gives us regular 4 plus h. Outer gives us 2 radical. Inner gives us negative 2 of that same radical. Those drop out. And then last gives us negative 4. And then all over, don't forget the bottom, the one without the radical to begin with, don't distribute that one, just leave it. Don't forget we're doing the limit as h approaches 0. We probably could have cut that off because what's the first thing we want to do? The 4 and the negative 4? Those take us to 0. And then what else do we want to do? Cancel out the h's. Now, if we cancel out the h's, what's still on top? Don't forget you still have a 1 on top, okay? And then, so square root of 4 plus h plus 2. Don't forget we're doing the limit as h goes to 0. All right, so now we can plug in that 0. We get what? 1 over square root of 4 plus 0, or 4 plus 2. Square root of 4 is 2. 2 plus 2 is 4. So, but that's on the bottom. So 1/4. What does that 1/4 mean? Slope. Slope. Beautiful. So we're ready to go. Y minus, we knew this. I'll begin with y minus 2, y minus y1 equals m x minus x1, which was 8. I can write that. I'll write that here. Y minus, what is it? Y1 equals m x minus x1. And then for me, that's okay. For the test, that would be okay. If we want to solve for y, to at least graph it, distribute. So let me just rewrite that. Let's see if I can actually rewrite it. What was it? Y minus 2 equals 1. Or actually, here, let's do this. Because you guys, does anyone still need that? What was it? Y minus 2 equals 1/4 x minus 8. That's kind of nice. There might be one on the homework where the fraction stays, so don't panic. This one, the 1/4 times 8 is nice. Gives you 2. Just be careful. Oh no, it does drop out, doesn't it? If you add 2, so it's just y equals 1/4 x. That's it, right? Minus, yeah. Okay, and that's okay too. Okay, so homework, only 1, 2, and 3. Only 1, 2, and 3, and that'll be plenty. That'll give you 3 to do. We'll see if we get to 4 or 5, I'll let you know, and if not, then I'll eventually just take them off, okay? But for right now, 1, 2, 3, it should be, we're back on WebAssign. Yes, just right. Literally 1, 2, 3 on WebAssign, and there should be 2 more problems. Don't worry about those. You might have time tomorrow. All right, good. All right, so look over, since there is only 3 problems, but I know it'll take you a while. If you want to look over your test too, don't hesitate if you have questions. Okay. All right, guys, have a good week. I'll see, who do I see tomorrow? Oh my gosh. Right, see A through.
Not me.
Oh, not you. It's been a while. So yeah, beginning of the alphabet, I see. Okay, beginning of the alphabet. Yep, wait, let me just pause this because we don't want to hear this. And then yes.
Oh, yeah.
Let's see. Okay, I only have 3. Oh. Stop.